This is video number 1 today, Wednesday, May the 8th, and this video it's for US Steel. And what we have here, it's a 3 phase full wave rectifier. We have our AC, we have our rectifier, and what we have is we have our on the DC output we have a shunt on the positive leg, on the positive bus, and we have 2 resistors across the DC output, and here we have our lamp load, and we're going to bring this output voltage to 260 volts DC. We have modified the ISO-1. Now we have 1, 2, 3, and 4 connections. We can see here all 4. Before, on a standard ISO-1 we only have 3, and I'll show that here we have the output of our rectifier. The negative goes to our load, but the negative also comes across these 2 resistors. We have a half watt resistor and a quarter watt resistor, so we come on the quarter watt resistor side. And on the negative, that's on the negative. On the positive, it comes here. We have this white with tape. We go through the shunt, comes out of the shunt, and it goes to R1. That's our positive. So we have R1 and R2 in between our negative and positive buses, and these 2 resistors are set so that in the middle we can pick up 4 volts with this orange wire and come to J1 position 1. That's the positive with respect to the black negative. So this one right here, it's J1 position 1, or voltage feedback, with respect to the negative bus. And we have simply the shunt across the shunt all through the positive. Remember, this is the positive shunt, goes through the resistor network. It also goes to the load, and just across there we have the current feedback going to positions 3 and 4. The side on the source of the shunt goes to position 3. The size of the shunt going to the load goes to position 4, and that's what we have here, current feedback, and we have voltage feedback. Now we are going to be recording the voltage feedback across R2 that it's being injected into the regulator board at J1 positions 1 and 2. We notice that we have our negative here and we have our positive, so that would be a positive voltage right here. Then we also are looking at the 50 millivolt shunt across the 50 millivolt current feedback across our shunt. And just for reference, we have our AC input, and we're gonna bring our sig high. We're gonna bring in this particular case our voltage or current commands to 260 volts DC. And one more thing that we're going to look at is the sig high. It's the delay angle command generated by a regulator going into our board. Alright, so this is the end of this first video.